Hello, welcome to Zigmatech Learning Hub. I will be your instructor for further mathematics. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, GCE, KCPE, IJMB, JUPEB, KCPE, BESE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. You're welcome to today's class. Our subject is further maths. We're going to deal with the topic differentiation. But before we start to learn, let us see our specific objectives. By the end of this lesson, you are expected to define differentiation, understand product rule, solve quotient rule problems, apply the chain rule in problem solving. Differentiation is just the opposite of an integration. That is, if an expression is given to you, if y equals 2x squared, the derivative of it, dy ds, equals 4x. Now, why I'm saying is the opposite of an integration. If a function is given to you, we're told to evaluate or simplify this. Evaluate 4x ds. This is the symbol of an integration. When you integrate this, it will give you 4 raised to the power 2 all over 2 plus a constant. Meaning, this divided by this, it will give us what? 2x squared. Can you see it? Is bringing back the question of differentiation. So, the solution of a differentiation is a question to an integration, antiderivative, which is the integration, y differentiation, the derivative. So, both of them are just opposite to each other. In differentiation, you have a general formula that will guide you in what you are doing. What is that? You have x raised to the power n minus 1 when the coefficient or the power of x is not greater than 1. That is, I have x. And when the power of s is also greater than 1, is also visible. But the one that is not visible is just this. But bear it in mind, this is power 1, but you don't write that in maths. What determines this particular general formula is the coefficient of x. When the coefficient of x is greater than 1, you can't use this. But when the coefficient of x is not greater than 1, you use this. Look at when the coefficient of x is greater than 1, meaning you are using an xn minus 1, where a is the constant. Look at this, 2. Here, a is 2. But if I have this, if y equals x plus 3, or y equals x, the formula is this, direct. Because the coefficient of s is just 1. Therefore, we don't need this constant. So, let us try to use this to solve for this. If y equals x plus 3, dy dx equals n. N means the power of s, all right. Multiplied by x itself is untouchable. Then 1 minus 1 plus differentiation of a constant is 0. This will now give us 1 times x raised to the power 0 plus 0. Recall that in law of indices, anything raised to the power 0 is 1. So this will give us 1 times 1, 1 plus 0 equals 1. Therefore, dy ds equals what? 1. But to test it with this, you will have that 2s squared, if y is the function of this, dy ds equals a, which is 2, multiplied by n. What is the n? The power. Then multiplied by who? X raised to the power n, which is the power minus 1. To give us what? 4x2 minus 1. To give us 4x power 1. To give us 4x. In indices, anything raised to the power of 1 maintains that same thing. So let us venture into the product rule, where the knowledge you have in this general formula have a role to play. Talking about product rule, in product rule, you have the y, the x equals u dv all over the s plus v du all over the x. General formula for product rule. For you is the first thing that will be given to you in your question. Let's say, how do you know a product rule? If y equals x plus 1 into x minus 3. So this will represent u, this will represent v. Now let us try to solve this. If y equals what we have here, find dy dx. Let u equals x plus 1. Let v equals s minus 3. Du dx, that is, you are differentiating u with respect to x, equals 1. From our general knowledge of differentiation, n s n minus 1, the power here is 1 times s, 1 minus 1, 1 times s power 0, 1 times 1, which is 1. You can see it. So the v, the x is also 1. The next thing you do is to substitute. We are applying substitution here. Since you have your value for the u, the s, and the v, the u, you now say dy dx equals u. What do you call u? X plus 1. Multiplied by the v, the s, which is 1, plus v x minus 3, multiplied by the u, the s, which is 1, to give us s plus 1 plus x minus 3 to give us 2x minus 2. If you like, you can say x minus 1 when you divide through by this. So the y, the s equals what? X minus 1. Let's take another sample on this. If y equals s plus 2 into 2s minus 1, find the y, the s. Okay, to do this, we apply the same thing we've done before. The formula is already here, and you have seen the meaning of u and v. So our u here from that question is what? X plus 2. And our v is 2x minus 1. Then du dx equals 1. While dv dx equals 2. So dy dx equals to u dv ds. What is u? X plus 2 multiplied by dv ds, which is 2, plus v du. V du is 2x minus 1 times du ds. Du ds is 1 to give us 2 times s is 2x plus 4 plus 2x minus 1 to give us 2s plus 2s is 4x. 4 minus 1 is 3. Therefore, dy ds equals what? 4x plus 3. Look at this. This was a product rule, but somehow complex. You have x sine 2x. Find dy ds. So in this, there's a touch of chain rule in that because sine 2s is already complex. So what you do, don't be scared of the question. See what you do. X sine 2x. Let u equals s and v equals sine 2x. But if you look at v is still complex. It's still telling us this is a product rule. Sine and the 2s in it. So what do? Handle this gentleman, that is dv dx. Since this thing is complex, just see it as a different thing. Assign another thing here, v1. Let v1 equals 2x. And let y equals sine v1. I want to handle it so that whatever I have here, you are bringing it back as dv dx. Now, dv1 dx equals 2. dy dv1 equals cos v1. By chain rule, you have that dy all over the s equals dy du times du ds. So when this cancel, it will give us dy ds. So remember, we are using v1 here. See it as this, meaning cos v1 multiplied by du ds, which is the v1 ds, is 2 to give us what? 2 cos v1. Recall that v1 equals to 2x. This will give us what? 2 cos 2x. Now, dv ds equals what? 2 cos 2x. Leave it here first. Then let us consider the u ds. The u ds is just 1. Then application, dy ds equals what? U dv all over the s plus v du. So dy all over the s equals u. What is our u? X multiplied by dv ds. Dv ds is 2 cos 2x plus v. V is sine 2x multiplied by du ds, which is 1, to give us 2x cos 2x plus sine 2x. This is the solution to this question. 2x cos 2s plus sine 2x. Okay. This is another product rule. I think this one is a bit easier. It's just that we need to find the y, the s when x is what? Pi over 2. A value was assigned to x. So let us see what happened to that. I'm still leaving the formula because still on product rule, but another form of it. So let u equals, the question is y equals x sine x. Let u equals x and v equals sine x. Remember what we did when we had sine 2x? Say let v1 equals x and y equals sine v1. So the v1 ds equals 1, the y dv1 equals cos v1. So the y ds equals 1 multiplied by cos v1. Recall that v1 equals who? X, meaning cos s. Okay. The u, the s equals 1. The v, the s equals cos s. Okay. Now we want to apply it here in our formula. What is u? U is x, all right? Multiplied by the v ds, which is cos s, plus v sine s, multiplied by the u ds, which is 1, to give us x cos s plus sine x. This is not all, but right, if value were not assigned to s, it means this is the final answer. But now they said when x equals what? Pi over 2. If x is pi over 2, this simply implies that our solution, x is pi over 2 cos pi over 2 plus sine pi over 2. This will give us pi over 2 is just 180 degree all over 2 cos 90 degree plus sine 90 degree. If you have this divided by this is what? 90 degree. Cos 90 is 0. Y sine 90 is 1. Meaning the y, the s at x equals pi over 2 is what? 1. That is 0 plus 1 equals 1. So 1 is solution to this question. The quotient rule. Quotient rule means division rule. In quotient rule, we have the formula like this. The y, the x equals v, the u, the s minus u dv, the s all over v square. All over v square. But remember that the first one is our u, while the second one in product rule is our v. Now, in quotient rule, numerator is our u, while denominator is our v. Take note of that. So, let u equals 2x minus 3, and let v equals 2x plus 1. The u, the s, v square equals 2x plus 1 all square. Then the u, the s equals 2, dv ds equals 2. Time for substitution. V du ds. What is V? 2x plus 1 multiplied by du ds minus u. U is 2x minus 3 multiplied by 2 all over v squared 2x plus 1 all square. It's your choice. If you want to expand this, fine. You don't want to expand it, you can leave it. This will give us 4x plus 2 minus 4x plus 6 divided by 2x plus 1 all squared. This will now give us 4s minus 4s gone. 2 plus 6, 8. All over what? 2x plus 1 all squared. Final solution. The y, the s in this quotient rule is what? 8. All over 2s plus 1 all squared. In bracket. Look at that now. Find one. Sine s divided by cos s. Like I said earlier, you don't need to bother yourself so much when you see this kind of question. All you need to do, apply the rule. You already know your formula, and our question is given that y equals sine s all over cos s. Find the y, the s. This is not just like the trig whereby you know that sine s all over cos s equals what? Tan s. In this case, let's see what this can result to. So, let u equals sine s, v equals cos x. We must not be going through the long process. Now we have known that differentiation of sine s is what? Cos s. Why that of cos s is what? Minus sine s. So du ds equals to cos s. Why dv du ds equals minus sine s. And v square equals to cos square s. These are what you have here. The next is just the substitution. You can see there's no more stress about this differentiation. It's just your ability to recall. You solve, you substitute, and get your final answer. Now we want to substitute to get our solution. We'll have that v du all over the s. What is our v? V is who? Cos s, okay? Times du ds is cos s minus u. What is our u? Cos s times dv ds. Dv ds v, okay, v is cos s, good. Then du ds. Du ds cos s, then minus u, or u is sine s, okay. Sine s multiplied by dv ds. Dv ds is minus sine s all over cos square x. This will give us cos s times cos s will give us cos square s. Minus this and this is what? Sine square s. Divided by who? Cos square s. Recall that from trig, we know that cos square s or sine square s plus cos square s, anyone can go, equals, implies what? 1. This will give us, this plus this will give us 1, all over who? Cos square s. Now, there is something I call the super hexagon. That super hexagon is where you can determine your values immediately. Let's have this super hexagon here. The super hexagon. If I have tan S, cos S, sin S, cot S, I'll draw my line to intersect them. The center is just 1. Sec S, cosec X. Now, if I have 1 over cos S, it will give me sec S. I have 1 over sin S, it will give cosec X. What about a case where you have square of it? It becomes what? Sec square X. The reason for this analysis, I want to interpret the final answer. Using this super hexagon, you're going to see that 1 over cos S square is going to give us what? Sec square S. Therefore, the derivative of sin S all over cos S equals what? Sec square S from our super hexagon. So that is the solution to that question. Chain rule is the next in this topic. The chain rule means function of function. That is when you have a particular function operating, another one is still in it. If you work very well, this is bracket open 2s minus 4, close it, raised to the power 5. You can see that the power is too much that it's not just ordinary square. We can say 2s minus 4 into 2s minus 4. You just expand, which is the product rule, but this one is now more than the product rule. That's why we are calling it chain rule. So when the power is higher than 2, you are making use of what? Chain rule. Now, we'll have this. For chain rule, dy ds equals dy du times du all over the s. Meaning, when I cancel this, I will get back this. But we are not canceling, except to have a number or something that can cancel each other when we solve. That is the only time you are allowed to do so. Now, you have 2x this. Let u equals 2x minus 4, as the case may be, and let y equals u raised to the power 5. We have two things here. So, du ds equals to 2. No cause for alarm because we already know this. Constant is 0. Then dy du equals to 5 raised to the power 4. Meaning the power is 5. Remember our general formula. You write 5 into the alphabet, then 5 minus 1, which is the 4 here. So dy ds now equals 2 multiplied by 5 u power 4. To get our final answer here, 2 times 5 is who? 10. 2 times 5 is what? 10. Then u, recall that u equals to who? 2x minus who? 4. Then raised to the power who? 4. Final answer. That's all. That's all. You don't need to stress yourself so much about this. Look at what we have here again. What is the derivative of t squared sine 3t minus 5? Still chain rule. Another complex one. That is the derivative of t squared sine bracket 3t minus 5 if y is a function of this, we want to know the derivative. This one is also a complex one, but no issue. This is product rule, but because it's complex, that's why we are calling it a chain rule. So let u equals t squared, and let v equals sine bracket 3t minus 5. If you look at this v very well, it's too complex. It's too complex. So what do? I want to come to this place. I will have a new v, call it v1 equals 3t minus 5. Then y itself equals the sine multiplied by v1, the new v. So let us take their derivative, the v1 dt equals 3, y dy dv1 equals cos v1. So dy du equals this times this, 3 cos v1. Recall that v1 equals what? 3t minus 5. Now we have what we need for the v dt, which is what? 3 cos 3t minus 5. Okay. Now we are not using just only chain rule. We have made use of chain rule where necessary. Come back to product rule, which says dy equals u dv ds plus v du ds. Now we already have dv dt. So what we need to do, let us get our du dt. Du dt equals 2t. This implies du dt equals what? 2t, because of the nature of the question given to us, that's t squared itself. So we have differentiated to get what? 2t. Now it's just to substitute our value. What is u? U is what? T squared multiplied by who? Dv ds, which is dv dt. So what is dv dt? 3 cos 3t minus 5 plus who? V. What is v? V is who? Sine bracket 3t minus 5 times who? Du dt, which is 2t. So let us finalize our answer here by saying that dy dt equals 3t squared cos 3t minus 5 plus 2t sine 3t minus 5. Final answer, because we'll count out two of them together. So this is the final answer to that question. So another one before we make use of our exam guide. What is the derivative of root 1 plus s all over 1 minus x? If y is giving us this 1 plus s all over 1 minus s, find the y ds. Okay, this can be interpreted this way: 1 plus s all over 1 minus s all raised to power half. According to law of indices, square root means power half. So let u equals the internal one, the one in bracket. Let y equals u power half. So what are we going to do? We'll have u, which is complex already. So we are going to create a new u, calling it u1. u1 equals, that is quotient rule. This u itself is just a quotient rule. So if we create new u1, we are trying to use the quotient rule to handle this case so that we know that the u, the s is whatever we have here. So let us have another u1, which is this 1 plus x, okay, all over 1 minus x. But looking up, we'll have this to be what? The upper one, u2 equals 1 plus s, then v equals 1 minus s, v square equals 1 minus s all square. The u2 all over the s equals 1. The v, the s equals minus 1. Applying quotient rule, recall that the y, the s equals to v, the u, the s minus u, the v, the s all over v square. Now this will give us v. What is our v? 1 minus s into the u, the s. The u, the s means the u2 all over the s, which is 1, minus u, which is the u2, 1 plus s, times what? The v, the s. The v, the s is already here, minus 1, all over who? V square. What's our v square? 1 minus s all square. Good. You know, this is just a careful process you need to observe while you solve. So what next here is this time this 1 minus s minus 1 times 1 is minus 1, then times minus plus 1. This is minus s plus x all over 1 minus s all square. So our du ds equals this here, 2 all over 1 minus s all square. Good. We'll have the u, the s. Now let us talk about the y, the u. The y, the u equals 1 all over 2 u, 1 all over 2 minus 1 over 1 to give us 1 all over 2 u into 1 minus 2 all over 2 to give us 1 all over 2 u minus half. So this minus half here simply implies that just take note of this place because I want to wipe it so that I can continue to enable me finish what we are having at end here. So what do we have now? 1 all over 2 multiplied by this means 1 all over u this. This will give us 1 over 2 times 1 all over root u. Do you agree? Yes. According to law of indices, anything raised to the power half is just square root of that stuff. Okay, now we have a fraction. We want to bring back the whole thing. Our interest here is what? The chain rule saying the y, the s equals who? The u, the s. What is the u, the s? 2 all over 1 minus s all square multiplied by who? 1 all over 2 times 1 all over root u. To give us what now? This can manage this, okay? To give us 1 all over 1 minus s all square into this to u. Recall that u is what? 1 all over 1 minus s all square times square root of 1 plus s all over 1 minus s. This will now give us, if you like, you can leave it this way, 1 all over 1 minus s all squared times 1 plus s all over 1 minus s raised to the power half. You want to expand here, fine. You don't want, then you can conclude it as your answer. So that is that. Du, dy ds equals 1 all over 1 minus s all square multiplied by what? Square root of 1 plus s all over 1 minus s. So let us take question from past question using ExamGuide. This is UTME question. If y equals 6s cubed plus 2s squared minus x raised to power s cubed, find the y ds. Okay, you just apply the general formula here by saying an s raised to power n minus this. This is not a product rule, it's not a quotient rule, neither a chain rule. It's normal differentiation, so you have to apply this formula by saying that dy ds, for the first one, a here is 6, the power is 3, multiplied by s, n is 3, minus 1, plus the second one, a is 2, the power is 2, which is n, times s raised to the power 2 minus 2, minus no a, but we have the power as 3, 3s, 3 minus 1. This will give us 18s squared plus 4x minus 3s squared. This minus this will give us what? 16. 18 minus 3 is 15 plus 15s squared plus 4x. You have 15s squared plus 4. Okay, it's like that. Okay, that's the sign for this is minus 3. So with based on plus, it will give us 15s squared plus 4. Now let us solve it with the minus sign and see what it will result to. This still maintains 6 multiplied by n, which is 3, multiplied by s minus 1, plus 2 times s power 2 minus 2 minus 3, s minus 3 minus 1. This will now give us 18s squared plus 4x plus 3s raised to the power 4. So what do we have? Minus 4. So it will give us 18s squared plus 4x plus 3 all over x raised to the power 4. When you differentiate, this is what you are going to have: 18s squared plus 4s plus 3 all over x power 4. That's what you have. That is the solution to that question. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and give a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.